Okay, hello everybody. My name is Nejc, and today I want to take you on a journey how I experienced hosting from my own server to now edge computing. And the previous talk was really great because it already told us how to offload from the main thread in the browser into the web worker. But now we will take it from the other side, how we offload from the cloud into something in the middle on the edge. So here it is. So let's go back in time, right? For me, it all started in my living room, XP, and I wanted to play with websites, right? So I decided to host some website, and that was not easy, right? So first, of course, I just started, so I had no idea what I'm doing. So I Googled a lot, and I saw that I need to install something called IIS. Great, I had something running. Now, the tutorial just said, yeah, enter the IP, and you'll be good to go. But of course, you have a router, right? So then I Googled how to allow traffic to go through the router to the internet. Great, that worked. But then I figured out that Telecom really hates me because they added me dynamic IP, right? What this means that every time the IP changes, so my website is always on a different address. I called them, hey, I really need static IP so that I can finally host my website. So if you look, hardware was me, software was me, and maintenance was me. So I know that this is not going anywhere. So after some time, I just find out about hosting providers. That was great because they took hardware and software from me, but still, I needed to decide a plan, right? How many emails I want, how many storage I want, all of these random things that, again, I had no idea what I want. And then I get something like cPanel or Direct Admin, where I configured some stuff, and okay, for the website, all was good. But still, the maintenance was there, still, I need to configure a lot of stuff. So after that, luckily, cloud computing came in, right? So everything is now a service. Easy to use, you just plug different stuff in, and it's just working. Pay as you go, so you don't need to worry about the plan or anything like that. And you have like AWS or Heroku, which are great, but they are really different. Why? Because AWS gives you a lot of options, like a lot, right? But I have no idea what I'm doing in AWS, right? You have so many permissions, roles, how to connect different stuff. So it's really hard for someone who is just starting with, I want to host a website, to actually deploy a website. Where if we look at the Heroku, their approach is we want to simplify everything for you, but stuff are still working interconnected between services. So how do they do it? They just give you options to connect. For example, you log in, you add a service, you attach a database, and they handle all the routing, everything in between. Where in AWS use case, you need to configure all of that, you need to configure the roles, who has access to it, and stuff like that. And one important thing as well here is that DNS, routing, all of this stuff is handled for you automatically. So again, hardware, software, everything on the provider. Maintenance really depends where you're going, which solution you're going, right? Heroku, simple to use. AWS, a lot of power, but you need to have a lot of knowledge. Now, we covered from the beginning, so hard to set things up, to now quite an easy things to set up, right? You don't need any hardware. Think even about what you need to do in a sense of hosting provider. But what's next, right? What's next that is coming? So on the left side, we have AWS regions. So these are data centers that are across the world, and they are basically hosting all the different services that AWS has. Now, on the right side, you see a lot more dots. Why is that? Because these are not data centers, they are AWS locations. So what's the difference? The regions have a massive data center where you have all their services, storage, database, processing, all the APIs or all the services that you can use. Where on the locations, this is their CDN, right? in there they have region, they have S3, they have routing, they have caching, and they have DNS, right? So a lot smaller things that they need to deploy, and because of that, and to set the whole thing up, and because of that, they have a lot more locations. And why is this useful? Because now the customer who is hitting that API is a lot closer to that service versus hitting only these regions, right? And this is the main point of edge computing, right? You want to be as close as possible to the customer as you can be, right? And edge computing is a network philosophy of bringing cloud closer to the source, right? And that's why I said the previous talk was a great example of edge computing, right? Because you're taking some processing that could happen on the server, put it into the web worker, and now you reduce a little bit of load from the cloud. And one of the approaches is also edge computing, right? So that you are not computing or doing things on that region anymore that we were looking before, right? So instead of doing everything in a small region, you can now do a lot of things in the location. So I think that a lot of you are familiar with Lambda. So let's take AWS example, how they switch from a regular Lambda to the edge Lambda, right? So if you take a regular Lambda, let's say the user clicks on a button which triggers an API call, right? These go through the API gateway, which handles the request, and then Lambda is triggered and processes the request. All of this is happening in that couple of data centers, right? But now in the edge Lambda, you don't go to the data center, you go to the cloud front. And cloud front is where these edge locations are. And the important thing here to note is that this CDN gives you caching, right? And why is this important? Because in some cases, you will not go even into the Lambda, because CloudFront will cache the previous request that came in, and you can just return. You don't even need to trigger Lambda. But if the cache, for example, was not hit, you go into the Lambda and you process it. So let's take an example of these two Lambdas, right? Let's say that we have a customer in Chicago, right? They do the same request. The regular will go to the data center in Virginia, right? But edge, because it's closer and its location, will go to Ohio, right? So we see that we kind of saved half of the path between the request and where it needs to be processed. So we just saw how what is the improvement from the regular Lambda from the edge Lambda. But now let's take it a step further, right? So we have a AWS CloudFront, right? They have more than 90 locations all over the world, right? Which is great, but now let's look on the other side. We have Cloudflare, which have more than 250 locations all over the world. Why is that? Because AWS, as we know, they started as a services, right? They had data centers and they gave you services. But with Cloudflare, they started with CDN. They started with bot protection, DOS protections, right? And they, instead of going with, hey, I have a data center, let me build something for the edge, they were always building the edge, right? So they already had the whole infrastructure ready, and now when it's time to do edge computing, they have a huge advantage, let's say, instead of AWS CloudFront. And the important thing also to note here is how they're doing things, right? So let's go into the Lambda again, right? So you see in the bottom, these are containers that are created for every Lambda, right? So Lambda is nothing else that Node.js virtual machine that is created for every request that comes in, right? So you have a lot of processing overhead because you need to spin up the Lambda, download the code, initialize, and then you execute, right? But with Cloudflare, they took a different approach. What they used is they used something called V8, right? So what is V8? V8 is an engine that majority of you are using on daily basis. Why? Because it's running Chrome, right? So V8 is an engine that is rendering JavaScript in the Chrome or in the Chromium under the hood, right? And every browser that you open in Chrome is its own thread. Why is this important? Because it's in own thread, which means it's sandboxed, it's protected, so it's not sharing data between one tab in the browser between the other. And it's really lightweight, right? So when you open browser tabs, you see it's instant, right? And it can load independently. And this is what Cloudflare took for the basis of their edge computing, right? So what they do, they create an isolate, which is V8, and in there, you set it up. It takes 5 milliseconds to create an isolate, but in there, you have a lot of threads, which means that when the worker is hit, they don't need to spin up the virtual machine or anything like that. They just need to spin up a thread. And that is done, as we will see, really, really fast. And because of that, they have, again, a huge advantage compared to AWS. So let's see how cold start is handled by AWS and Cloudflare. So what is cold start? Before, we were talking about virtual machines and process overhead. So this process overhead is cold start, right? So how long does it take for a request to be processed when nothing is set up, right? So in AWS Lambda, what needs to happen, right? You need to download your code, start the new environment, initialize this environment, and then execute the code, right? Some tests that I was looking at, this process can take around 1 second to be spin up, right? Of course, AWS knows that this is a problem, so because of that, they allow you to do provisioned concurrency. Of course, you will pay more money, but you will have kind of allocated lambdas that will spin up faster, right? So this is a problem because how the basic of Lambda is done, right? Virtual machine. Now, if we look at the Cloudflare worker, you have a thread, so it's a simple thing to do. So let's look at here, right? You have a request that comes from the browser, right? So first thing in the request, what the browser needs to do, it needs to check if the certificate is okay, right? So that's that log that you see in the browser that it says if it's HTTPS and if certificate works or not, right? So in this, it hits the Cloudflare. Cloudflare will say, yeah, certificate finished, Cyper, and then it will do an actual HTTP request. But what Cloudflare does here is when this initial request to get the certificate comes in, they already create a thread. Because for them, it's really simple, right? So thread is created, they load the worker, they compile it, and then when the actual request comes in, the worker is ready. There is zero cold start. It just works, right? So this is really interesting how they approach this problem. And one thing that I'm seeing right now with edge compute is that a lot is put into the building of new features, right? So what they built already, they built storage, S3 storage on the edge. They built key values, durable object, routing, computing. They're even building the SQLite database on the edge, right? So you would be able to use a database on the edge, again, closer to the customer. Of course, they have a DOS and bot protection, which sadly I needed to use yesterday because one customer was attacked. And because they all have all of this, we just applied the DOS protection on the worker, and we mitigated the whole attack. So they're building a lot of these things, and to me, they are way ahead of others in this regard, right? Fastly is also a CDN provider that is building these capabilities, and Akamai, they are mostly focused about the video streaming, but they are also quite advanced already on the edge technology. So a lot is happening in this space, and they're moving really, really fast. So I'm really happy and bullish about the whole edge compute, because I think there is something there. So instead of me talking a lot about what is happening and how it works, I just want to show you how to create your own first edge worker and how to deploy it. So let's switch to... Okay, so this is completely brand Cloudflare account, and you see on the left side I have workers. So I will create my first service, right? We can just call it JS-Tech. And for everybody that is starting with this, you already have like a starter pack that will give you a little bit of code so that you know what you need to do. So we will just select an HTTP router so that we can see how the routing works here. Okay, right? So the worker was created, and if I go now here, you see everything is already set up, right? I can already use this service. Now let's quickly edit and see what we actually did. And let me see if I can hope, yeah, it should work, right? So this is your default setup. At the beginning, it's a like default function with have a fetch, which is receiving the request, right? You get the request data, and you have environment variables, which I'll be talking a little bit later. And then they give you like a handle request function, which is something that is like a default name to handle these things, right? So let's see what we are doing in this default starter, right? So we have something called path name starts with API, right? Which means that we get the request URL, we get the path name out of it, and then we check if the API is there, right? So let's see what happens if I go here. So in here, at the end, I will just do /API. API. Right? So I get back /API path name, right? So I can do even /API/test, and it will give me the whole path, right? So this is like a really simple GET request. Now, if we go further, we see that they also give us something called status, right? So let's see what this status do. Status, and we also need to do something else, right? We need to give them the status code, right? So let's say status 200, right? So we get a lot of gibberish here. So because of that, I will open this in a new tab, and I get the cat 200, right? So I can now play with these status codes, and yeah, this is their default example. This is not me. So they're really funny about these kind of things. So you see, this small snippet gives you already the whole API to process the request, to return something back, or do gets, right? Now, one thing that I was mentioning is that you can also store on the edge, right? So one thing that I want to show you is how to store something into key value storage, right? So let's go back. And in here, I have key value option, and I will create a namespace, right? So I just do KV test. So what I did right now, I just created a namespace where I will be storing key value data, right? I will open it in a new tab so that we can then check the data there. Now let's go back to our worker and actually put some code in there. Okay. right? So I will not bother you with me writing a code because it will be too slow. So let's look at what I just pasted, right? So I did two things, right? I did a post to store and a get, right? So let's see what we did, right? We did a request.method to just simply see if it's for get or not, right? If it's a get, in the environment variable, we'd get key value name, right? I see that in here I used kv demo, which means that I will need to fix it to kv test, right? And then in there, what I will do, I will just get the path name and store it in there, right? Or sorry, get it from there, which will be my key. In the post, I will try to save something, right? So I will parse the JSON, and I will just do a simple put, right? And in that JSON, I will just put two things, key and value, and save it, right? So let's see how this goes, right? So I will change from get to post, and now I will do a key, which will be Ljubljana and value. Tech, right? So this is now what I want to store, right? Key will be Ljubljana and value will be tech, right? So I get 200, and no, I don't get key value. Oh, thank you. It works if you save it and deploy it. But you see, it was saved and deployed in a second, and that should be it. I did post. Let's see what the error is. Let me just reload it. Right, so let me do post again, and I will do key and value. Okay, let's try now. Oh, cannot read property of, oh, of course. One thing that I forgot to do is actually link this key value storage to our worker, which would help, right? So I created a worker, but I never linked it to the worker. Sorry, I created a key value namespace, but I didn't link it, right? So I need to go into the worker, settings, and in variables, you see you have key name namespace binding, right? And here, I need to actually do this connection. And that's why it said I couldn't find put, right? Okay, so let's try again. Okay, success, right? So let's go, let's try to reload it here. Yeah, you see, now we stored Ljubljana and tech, right? So now if I do get, and in the URL I will just put the name, which is Ljubljana, if I'm not mistaken. You see, I get back the data tech, right? So this is a really simple example how you can create your own key value namespace, how to connect it to the worker, which is always good, and then how to write a simple worker to do it, right? So now we experiment a lot with Edge, and the solution or the technology that we are using with us is basically we are trying to offload as much of the stuff that is happening on the browser into the Edge, right? So what we are doing, we are simplifying the whole infrastructure for the customer, which means that everything that you saw here where I needed to click add worker, create key value, connect the binding, environment variables, all of this stuff, we do all of this with a couple of clicks in our app, right? Because we are using Cloudflare APIs to do it. Cloudflare has a really good APIs to, basically you can create everything that you want with just an API, right? Everything that I clicked here through the API. You can deploy the script through the API, which means that our customers are basically never know about Cloudflare in a sense. They just enter the domain that they want to do, enter which providers that want to deploy, and that's it. And what we are trying to achieve with our solution is that you have Facebook Pixel, you have the TikTok Pixel, a lot of this tracking stuff, and you have a lot of analytics and third-party solutions, right? So what we are doing, we are actually deploying all these third-party things into the first-party context. This means that we are deploying it into your Cloudflare and offloading all of that stuff into the worker. So before, you needed to load 20 scripts on the site and do 20 requests in the browser. Now you do one request with our script to the worker, and then you can spawn 20 workers to process that request, right? Which means that the site is a lot faster. There is no junk JavaScript or anything like that. Our SDK is 2 kilobytes big, and then everything is happening in the worker where we manifest the whole thing to the APIs, right? So this is, for example, our use case, how we are using the edge workers, and it really simplified the whole tech for us. Thank you very much.
So much for this. This was like seeing the deployments that's faster than my Webpack running locally, so kudos. My question would be, is it only JavaScript that you can run there, or are there any other languages that you can use?
You can do assembly as well, if you want. Vasm. But yeah, of course, everything is JavaScript based, so yeah. But yeah, if anybody wants to write in Vasm, go for it. You can easily deploy that as well.
Easy.
Sorry. Sorry, I was first again. Thanks, Nate, for this advertising for Cloudflare. But it was very insightful nevertheless, so that's okay. What is so talking about Cloudflare, not about your company, what is the developer experience once you get tired of using the browser for coding? Like, can you do version control? Can you do unit testing somehow on your machine, or are you forced to use this browser?
Yeah, for sure, right? So one thing that you have with the workers is you have something called Wrangler, which is the CLI that you can put on your computer. And then you have Miniflare, which is again something used to do a local development of the workers, which means that basically you can do everything that Cloudflare is doing here in your local machine without internet. Right, so they're mimicking all the requests, mocking everything. So yeah, you can work on a plane and work with workers, key value storage, everything. They're doing it in the local, right? So development experience for me was really good in that sense. And because you have access to their APIs, it's a lot easier to do all the deployments as well, right? And when we were checking, and that's why I was talking a lot about Cloudflare, is because we just saw that they're way ahead of others in that area.
When it comes to, for example, unit testing, do you have like a framework for that, or use these Wrangler tools, or that have that built in to make it easy to test the code? Or?
Yeah, through this Miniflare, you can mock everything and go through it.
Cool, thanks.
Right. Sure.
Thank you. It seems that workers are really good for parallel processing close to the customer. What is a good strategy for synchronizing data? So like having centralized database, does Cloudflare provide something for this, or is it better to call AWS or something like that?
Yeah, so it really depends where you're used to store the data, in a sense, right? Because we see a lot of customers are used to AWS storage or Snowflake or any other different storages that you have, right? So you can always connect a worker to that, because one thing that is happening that we are also doing is you can actually return a success from the worker, but still leave the thread open, right? Which means that you can do a fast response to the browser, say, yep, I received all the data that I need, and then worker actually process asynchronously to your data center, and you also have like a cron jobs, which means that you can set some kind of a state in the key value storage saying, hey, this request failed, retry it in 5 minutes, right? So all of that is possible already, and like I said, it's in alpha, but they have data SQLite database, so you can try that one as well. I would say it's not ready yet, because what they're doing, it's quite funny. They have database in one location, and they're just sending data from different edge to that one and then syncing it. So it's not ready yet, because even for testing, I tried it out and it's still quite buggy. So, but it's good that they are thinking, hey, how can I put the database on the edge? Right.
Cool, thanks.
So you mentioned that the reason for there being more edge locations than data centers is that they're essentially running less physical infrastructure on those locations, if I'm not mistaken. Have you noticed, let's say in the case of AWS, any difference in computing power between those lambdas at edge and lambdas on the data center?
No, the lambdas are working exactly the same in a sense. So there is no performance hit because of that, right? But because I'm not expert in how they deploy the data centers, but my feeling is that all the services that you have in the data centers, they just replicate it to the locations, but because they need to set up 3 instead of 200, it's a lot easier to deploy multiple even in one city, right? They have like 20 or 30 locations in one city in the dense areas. Right.
Okay. Thanks.
Sure.
Any more questions? Okay.
Awesome.
Thank you
very
so much for your talk, Nejc. And thank you all for...